So before we move into our chapter 4, right? You have to go through the two lecture in chapter 4. Yes, how many of you have watched? Only one, 2, 3, 4. Okay, some of you have. You belum? Yes, okay. Tak apalah, tunggu sini lah. Now, before we go into the discussion on chapter 4, just to refresh on several things. These things you have. So I'll just go through the slides. This is the light. So you can still see it. Anyway, so hopefully this is already part of your routine with Quran. Now, are you familiar with this verse? Not familiar? So I will instruct to give tazkirah, reminder, because it will be beneficial for the mu'min, right? And by definition, tazkirah is a reminder, meaning that something you already know, it is a reminder of. It's not like new knowledge, right? So based on this verse, I think if any of us who tend to behave in a way that when there's a reminder being given, meaning you dismiss it because you already know, right? Dah dengar dah ni, right? Because Allah says for mu'min, it will always give you benefit, right? So hopefully we are among them. And the biggest reminder is the next ayah. How many of you, what is the next verse? Yes, وَمَا خَلَقْتُ الْجِنَّ وَالْإِنسَ إِلَّا لِيَعْبُدُونِ. I think most of you are more familiar with this verse. Right? You have to SPM boleh jawab tu ya. Kalau SPM tak ada keluar. Kalau tak ada subjek agama. Ada. Oh juzuk 30 juga. Apa yang komen dia? Oh tak ada kau anda tu. Because I think this verse is very common, right? Meaning the purpose of life. Okay, how many of you think you have already practiced this verse? Okay, anyone who do not understand? No one. So everyone understand, right? No. Wama khalaqtul jinna wal insa. So, and actually this Allah made the claim, right? I do not create jinn and human being except for them to worship me. That's the normal translation, right? Although I didn't like that translation that much, but we'll take it, right? Yeah, or become abd, become my servant, right? And normally, because of the understanding of this word, we tend to think that we are in good place with this verse, right? Because normally when people think about ibadah, they think about solat and what to time today, right? So we don't have time to go into detail with that, right? But Allah actually goes. How many of you are familiar with the next verse? Ma uridu minkum min rizq wa ma uridu an yut'imun. Innallaha razzaq, right? So quite interestingly, Allah mentioned that this is our purpose, and this is not. And the contrast is there, right? However, I would argue that most of human beings, including most of Muslims, their life is centered about this one and this one. Cari makan minum dan cari rezeki, right? So, I would like you to think that if most of our life, right, from kindergarten to school to secondary school to university, and then you work until you're retired, it's mainly because the issue of risk. You want to find risk, and you want to find food to put on the table. Allah mentioned clearly that's not your purpose. Your purpose is up there, right? So this is among the things that I think most of us do not reflect that much upon. And the worst case scenario is we will be regretting it in the afterlife, right? Right, so that's a reminder for today. And now, because we don't have the time to go into detail here, right? But there are several things like this that I would like for you to be able to reflect, even though this is not the subject, right? But I'll just insert bit by bit, right? From my perspective, my duty here is to make sure that you understand the course that I'm teaching, right? That's statics. So I'm doing whatever I can. I believe I tried my best, be it from whatever methodology that I apply, right? Not to say I'm the best lecturer, right? But I'm saying in terms of the effort, I'm trying the best that I can. However, I also deeply believe that, just imagine two extreme scenario, right? One is a very good student, score the subject, get 4 flat, etc., graduate, get a good job, but he is not fulfilling his purpose, and na'udzubillah, he end up in hell, Jahannam. I'm not saying who scored this one will go there. I'm saying that imagine two extreme case, right? And one who is a bit slow, he have to repeat the subject, whatever. Cannot finish in 4 years, have to extend, whatever. But he is fulfilling his purpose in life, and he end up in heaven, in Jannah. Now, if you imagine someone asks him there what he's feeling, is there any possibility that in Jannah, the guy that when people say, how do you feel? Yeah, Jannah is cool, right? But I still regret not getting A in statistics. Is there any possibility? No way, right? Or is there any possibility, you ask the guy in Jahannam, he said, oh, it's hot, but I still, at least I score. There's no way, right? So from that, I hope from your perspective, hopefully you see that it is not worth to risk your akhirah just to pass an exam. I'm not saying do not study, but I'm saying do not cheat, right? You have to study to score. As a Muslim, Allah asks for ihsan, itqan, etc., right? We have to excel. But do not go in a way that will jeopardize your akhirat. So that's number one. And number two, also, I deeply believe that even though as a lecturer of this course, I want you to score this one, but it will be pointless if you still do not know what your purpose is, etc., etc. So that's why I try to insert when I can. Now, however, the thing is, moving onwards, our chapter will be, sometimes the expression is getting more thick and fast, meaning the content will be heavier and heavier, and we will not have any of this opportunity again. I cannot spend this amount of time to divert from anything like this, right? So, just in case if anyone is actually interested in this kind of discussion, so you can just fill there. You can take this one, whether you want to fill it or not, it's up to you. I just want to see whether if anyone is actually interested or willing or able for any discussion outside of statics class. Right? So if you have any comment, question, etc., it's up to you. So that's just an avenue, because I do involve a lot with students in this aspect, where I think if I can get the result there, it's much more rewarding than just getting people to get A, etc. Right? Anyway, so that's just right. So now we are in chapter 4. However, because some of you are not or haven't actually gone through the lecture, so just so that you will be not totally in the dark, you still have to watch them for the concept, understanding, etc. But at least we'll just put the equation here so that you know whatever we'll discuss. Okay, that's the equation. Right. So there's two video, right? I've posted. How many of you have watched post? 1, 2, 3. Post video. Right? So we actually have covered by the way, just to understand, for those who didn't watch yet, is the reason because we are still focusing on chapter 3 because today's is quiz on chapter 3 or not related? Yes. Okay. In that case, because that would be my worry, if our quiz is delayed from the chapter, then yeah, because your concern is more on the quiz, right? So you will not watch according to the time there, right? So I prefer after this, the quiz is not too much delayed so that we will not, because psychologically you concern more on the quiz, right? Okay, but by the way, so anyway, we have covered that two concepts. All right. Moment about a point and moment about an axis. Okay. So I'll be mainly there. Can you see that? If you cannot, please rearrange yourself so that you can at least see. Right. So basically, moment, what is it? It is a tendency for rotation. Right. So that's basically it. So in terms of the equation, okay, how many of you have watched what is the equation? Because we have scalar and we have vector equation. Do you remember moment about point? What is the equation? With m equals f times b. Vector? M cross f. Right? And here we will actually apply cross product using the matrix. You have learned that before, right? What about moment about an axis? What is the equation for scalar? So it's the same. Vector? Right? Can you see? Now, actually, if you write this u in front of, at the back is the same, right? When you dot, you can a dot b is equal to b dot a. However, we normally write u in front so that you will not make mistake in terms of when you apply in terms of the matrix. It will be here ux, y, z, rx, ry, z, fx, fy, z, right? So that it follows u rx. So that's why. But if you write r cross f dot u, it's still correct as long as you have the bracket. Alright. Now, m equal to f times b is just force times the distance. And the distance, what is the characteristic of the distance? It must be perpendicular to the force. Alright. So it depends whether we will see some past midterm questions. So it depends whether you get a 2D or 3D. Normally in 3D, vector is the easiest one to deal with, right? So normally moment about an axis almost always 3D. But moment about point, it can be 2D or 3D. Right? But you have to know all in order to answer any type of question. Alright, so let's take a look at, so that's basically the equation and we will see how we apply in different. Okay, this is. Oh yeah, by the way, because I'll just go through until the end of the actual tutorial time. So for those who have class at 4:30, just ask for excuse and you can leave when it's time. I think almost time already, right? Anyway, so for this one is 2017 and 18. Alright, so we'll try to do as much as we can. Right. Okay, this question is about moment. So how many minutes this question? Okay, this question actually is being divided into different portion and each have its own mark. And this question is actually because depending on the semester and depending on the lecturer that make the question also, this question is actually it already segmented the question so that it's basically step by step of answering. For example, express force in Cartesian form, etc. Right? We don't normally do that, but in this semester, the lecturer feel that okay, this student this semester is too bad, so we need to help them. So that's how it becomes like that, right? So do not expect every time it's like that. Alright, so but anyway, so this is the diagram. Okay, the one that we are focusing on is okay, determine the moment of force F about point C. Express the answer in Cartesian form, and then determine the moment of force about line DE. Express the answer in Cartesian form, and this one is right. Now we have some moment that we haven't covered yet, but in this question, all of this we have actually covered. Okay, can you tell what's the difference between these two? Yeah, this is by the reading you should already be able to tell, right? Moment about a point. This is moment about a line which is an axis. Right? It will not always use the word axis, but when it is a line, you know an axis. Alright, so what to do? Okay, let's address question B. If let's assume question A didn't exist, right? That's part A, because we'll straight away. So if you get the diagram and you need to answer part B, right? What do? First, you need to understand the question. Okay, this is moment about the point. So, which equation do you want to use? M equal to MD or M equal to R cross F? Okay, it's basically 3D. So to do this one, it will be much more difficult, right? And time consuming. So for this one, you know M equal to R cross F. So we need R in vector form and we need F in vector form. Can you determine both two? And please try now. Okay, before you try that, to finish this one, F will be which F? From point what to point what? FAB, right? R? R which R? AC. RAC. Around agree? RAC? Okay, this is about which point? Point C, right? So what's the concept? So we have the point C, and then we have the force acting at point A in that direction, right? So R is from where to where? From the point to the force, right? So R should be here. So R, CA, right? So this should be R, CA. Understood? If you understand, please try and see what you get. If you have any question, please ask. question? Any problem? I haven't decided, but probably if there's a quiz, it will be for this department on Thursday. On Wednesday, right? Any problem with any of this? Anyone calculated? Anyone actually calculated the vector F? Apa ni? 100i. 400. 150 plus 150. Then
Negative 300.
negative 300. Okay. Everyone get same? This one the same? One over five. Or 105. 100 or 105? This one is it? So the U what you get? And the R what you get? Okay, this is the same. 5 plus 7.5 minus 15. R what you get? 17.5. So you multiply 350 times 5 divided by 17.5 is what you get? 100. Correct. Alright. The rest is okay. So after that, what do you do? If you apply this one, then I, J, K, you put R here, 0, 15, okay, right? Is correct? And then 100, 150, minus 300. And then which will you solve? You use you close. So you get I, 4, 5, 0, 0. And then, then minus J, 0, minus 1, 5, 0, plus K, 0 minus 1, 5, 0, 0, right? So again, minus this, because I didn't count it. Minus 15 times 15, right? 2250. It's minus also, right? So you get minus 6750. And then plus 1500. And then minus. Is it minus? Is it the same? Any mistake? So minus 6750i plus 1500j minus 1500k. How much? So that will be the answer for what is the unit? Newton meter. Meter. Right. So Newton meter. So we have solved for part B. What about part C? Any question before we move on to part C? Any question here? What's going on? Apa tahu? Okay. Kita tengok apa? Okay, kita okay ke? Kita tengok apa? Kita sedang apa? Kita tengah tengok check nombor. Okay, so I'll right? So for part C, it's moment about axis. So this is the equation, right? Moment equal to U dot R cross F. So okay, so it's moment about line DE. What is U? U, which U? So it should be U DE, right? Because that is the axis. R. Flow, because R should be from which one point to another point, right? So what point? Which point? Okay, in terms of the concept, U is for what? Diameter of? No, I mean from the original concept, M equal to U dot R cross F. So U is for what? For the axis. So this one the axis. R is from what? From axis to force. F is force. Right? So for which point can you take as the axis to force? Because the axis is here. Right? So you can point any point here to the force, right? So what option do you have, for example? D? A. So that's one choice, B, A. So you can use RDA. RDA is okay because it is from the axis. EA, okay? Yes, you can. However, there's no distance there. You have to assume. So that's why. But if you have the information, that's correct. Any other option? AO. Oh, sini. Yeah. AO or OA? OA. It should be from the axis to the point and to the force. If you go the other way around, that's wrong. So OA is also valid. OA. Any other option? Just theoretically. Because some of this is easier to calculate than some. Can I use RDB? Can I use RDB? Okay, so yes lah. Can you imagine if I draw the force along here, right? And this is the axis, right? So anyway from here to anyway from here is okay. So RDB is also valid. You can try. If you use any of it, the answer will still be the same. So you can try. One use this one use this one, and see what happens. It should be the same. Right. So for F is the same, right? So F is this one, right? R will be okay. So UDE. What is the vector? UDE. Okay, is there any other than DE? DO. RDO? RDO. UDO? OD? I, right? I or negative I depend on which direction you are considering. DE or DO or OD or. But if DO, then it will be minus. If DE actually minus I. If ED is actually I, right? Because it's that x-axis, right? Okay. So 1I plus is basically 1I plus 0j plus 0. Okay lah. So if you plug in that equation, right? What will be the matrix? So n into so what's the first line here? From this one. What do you write here? What? Negative? You want to use negative? Okay, they're different. Okay, which one are you using? Because it's okay if you use whichever direction, and because in the end we will know is it positive or negative, and then we know actually which one the direction. So right now let's use positive, so it's actually ED, whatever. ED, right? So if this is 1, 0, 0, what do you write here? 1, 0, 0, right? Do not write I here. Do not put IJK here, because this is replacing that IJK. And what's next? The R. So which R are we using? If I use the easiest, I'll say RBB. Let me use RBB, because BB is a straight line. So it's 0, 17.5, 0, right? And then force is 100, 150 minus 300. It's the same vector just now. You can solve, right? If you use a different one, okay, in this case, what do you get? This will be easy because it will be. Okay, how to solve this? Okay, if you use this one, right? What do you get? It's actually 1. Yeah, 0 minus. Sorry, this one is. What is it? 17.5 times minus 300 minus 0, right? This minus this one, right? And then minus 0, because this 0. Before it's IJK, that's what IJK. Now it's 100, 100 lah, Ustaz. Tapi dah kosong apa dalam tu. Right? But you can put, because meaning that this 0 is actually 0 minus 0, right? And then this one is actually 0 minus 1750. Something like that. And then you get negative 5250 unit. Meter. This is still moment. Right? And you can see the unit, right? This is no unit, this is meter, this is Newton. So meter. What does this mean? It means that it's actually opposite of this. Meaning that we assume it's I, your thumb is I. So the answer negative, meaning it's negative I. It's clockwise. Meaning it's clockwise or negative I direction. You can try some other R, and when you plug in here, it will be the same answer. Any question? Is it clear? Okay, good. Okay, you tak? Okay, sebab tak tengok kecil lagi. Okay, so I just refresh the concept. This one, okay, let's say, of course you have to watch the whole video for the whole explanation, but I just simplify it here. If we have a point, let's say point O, and then we have a force here, right? And the question says what is the moment created by this force about this point O. So I can use this R cos F, which definition F is F. R is from the point to the force. So it can be like this. Or it can be like this. Or it can be like this. All will give you the same answer. Right? So that's why we tend to use this one. Because if you use F times D, D must be the perpendicular distance. You cannot just randomly state. So that's the concept. Okay. That is about the point. But when you have about an axis, so let's say you have a certain, let's say certain axis there, right? Whatever axis that goes through the main point there, right? So for this one, what is, if the question is what is the moment of this force about this axis? So this is the equation. Moment of the axis. So this U is the U of the axis. The axis itself. So it's U of this one. So if you have to calculate, you get the 2 point, then you get R, and then R divided by magnitude, you get the U better lah. This R is from axis to force. Meaning that, let's say from this point to this point, or this point to this point, or this point to this point, or this point to this point, all will give you the same answer. As long as it is from the axis, from anywhere on the axis to anywhere on the force. So that's why here, if the axis is here, and the force is here, so it's from here to here is okay, from here to here is okay, from here to here is okay, from here to here. So that's the definition. So when you ask what is this U is for the axis itself. So you have to look at the line DE then. Sometimes the question says about x-axis, then I know about y-axis J, or about whatever axis, and so. Is it clear the meaning of the question? Because for this you will have also its own R, its own U, right? This one is also R. So do not confuse all of those things. So this is for the axis, this is axis to force, this is force. This is point force. Okay, you want to see question for different item? This is from 2007. Okay, that's part C, right? Okay, we have calculated, right? Without any calculation, can you determine which will be larger between moment of force about line AC and moment of force about line BD, and why? This is understanding question. Which one is larger and why? Oops. Can you imagine the okay, line A, which is line AC. Okay, this line AC and the line BD. BD. Which one will be larger? How many of you say about AC is larger? About BD? I think someone said same just now. Why?
Because there's the same distance.
From where to where?
A to C, B to B.
Oh, this one and this one is the same distance?
A to B.
A
to B.
This one, A to B.
And B to B.
And this one? How is it the same? You have calculated? Or is it seem like the same? Okay, this is okay. Okay, in any of these, right? What R will you take if you want to take? Because this is moment about axis, right? Okay, let's consider the first one about AC. What R will you take? RCA. CD. Okay. That is for the. You want to try? Okay, you can try. But do you realize that the axis itself and the force coincide? If you take this is the axis, right? And the force is going to the axis. What will be the moment? Okay, imagine. What will be the distance between the two? If coincide, it will be 0, right? Line BD, right? This is line BD, right? This is the axis, and this is the force. It's actually coincide. So this is the question to see whether you can understand it or not. When it coincide, R will be 0, or distance will be 0. If you do not trust me, you can try. Okay, let's use conceptually RCA can be used, and then what will be the unit vector? But you can try. But basically the concept is like this. If in 2D, right, if you have for a point, force, this is the distance, right? So the larger the distance, the larger the moment. So when it's coincide, distance is 0. So there's no moment. It's like, I think in the lecture I put an example if you want to imagine, right? If you have someone push down here, right? You will feel that, here you will feel that sense of rotation. So when you want to counter, it's not just pushing up, it's actually counter the rotation, right? But if you push here, when the distance is 0, there's no rotation. You don't feel the rotation. So, itulah. Okay. Tak boleh ngomong kali. But hopefully you can answer that one. Let's try this one. Hopefully you can try all of them first. Alright, this one is an easy one. Determine the resultant moment produced by force F1 and F2. Okay, this is 2D. You want to try this or it's too easy? However, you have some angles here that you have to deal with. You understand the question? This is basically just using M equal to F times D. Because this is 2D, right? What is the resultant moment produced by F1 and F2 about point O? What do you do? You want to use the vector? No. You want to use scalar or vector? Scalar is easier. But how? Can you try and see whether you see how to solve or you are stuck somewhere? Okay, for those who haven't seen the lecture, okay, for those who have, what do we do in 2D normally? What do we do? How to solve? You resolve the force, right? Into x and y. And then you can get the distance x and y component distance, right? So please try and see. Anyone face any problem or not? If no problem, you can see different question with 3. But if you have a question, please try and ask question and try to understand now. So that if I give you the quiz next week or next class, you know what to do. What? Oh. Sorry. This one is, what's the title? This one in terms of the title, in terms of this one is 17 March 2018. Dapat tak? Cuba. Ke lain. Lain. Itu title saya kan. This is Sem 2 7 bulan 18. Oh lain. Midterm. Sama betul? Mungkin lain. Ini final ni. Kalau ada benda ni. Okay, the rest of you okay? Basically the idea is okay, then I always say that you should be able to highlight or pinpoint what is the important information, because not all information might be useful or needed, right? So the only thing that I did is where is point O, because it says moment about point O, and then where is the force acting there. You have two forces, right? So that's the only thing that I need at the beginning, right? Well, of course I want to resolve this one. So this one is already 20 limited. Fine. This one you can resolve, right? So this one becomes 30 sine 30 degrees. This is 30 cos 30 degrees. So meaning that these are all the active forces. The x and y, right? Until this one, okay? So and the distance that I need is just this distance and this distance, right? Because that's the perpendicular distance here, that's the perpendicular distance here for both of these. So can you get that distance? This one is what? It will be 3 cos 30, right? This one will be 3 plus 3 sine 30, right? That's the distance. Up to this one, okay? Because we don't care about the shape, etc., right? I just want all the perpendicular stuff. So with this, okay, because the question actually asks for resultant, so I'll just consider all, right? If the question say separately for F1 what is the moment, for F2 what is the moment, you cannot do in one go. You have to F1 one story, F2 one story. But if resultant, you just add the whole effect. So we do summation of moment is basically summation of F times D. Let's consider clockwise as positive. Counterclockwise. This is counterclockwise as positive, right? So for this 20 kilonewton, positive or negative? Why positive? Why negative? You have to say either clockwise or counterclockwise. It's not right to left, right? So in this case, it's counterclockwise, right? Can you imagine? So in that case, it will be positive 20 kilonewton times distance of
3 cos
3 cos 30. All of you can see this is the distance? Kita tak nampak? Because this is the form, right? So the distance is perpendicular here. If you can kind of confuse, you just make the force long. This is where the perpendicular distance is. Because some students, when the force is here, they cannot see where is the distance. So just panjangkan je lah. So for this 30 sin 30 is clockwise or positive or negative? Why? Because it is clockwise, right? So 30 sin 30, what is the distance? It's the same distance there, right? 3 cos. Okay, this 30 cos 30 force downwards here, is it producing clockwise or counterclockwise? Counter. Can you imagine or you just follow someone else? 30 cos 20. Pak macam ada yang cakap clockwise lah tu? Counter. You can imagine, right? Or some of you cannot imagine what apa clockwise kan? What? So how many? Whoever watched my lecture, what do I do? I use the paper, right? So if you cannot imagine, let's use this one, right? Meaning moment about point O is basically you pivot point O. And then this force pushing down, so if you push this down, you just see where the rotation, right? So it will be like this. This one, if you push there, it's still like this. This one, if you push here, you go that way, right? You just pivot, you just choke as well. This one, because point O. Okay? Just pivot and then this one push down. Push down here, right? Just you. Itu boleh pula. Tunjuk lah. Make sure you understand. Jangan faham lah kat nanti. In the exam you have to be able to visualize that. So the answer will be that. I'm not sure what is the answer. If it's negative, then it means that it's actually clockwise. If it's actually positive, then it's counterclockwise. So this is how you solve if it is 2D. You realize that in 2D, all this positive and negative you have to understand. In 3D, counterclockwise is automatically but from R cross F. Whatever is you get from the matrix, that's I, J, K plus and minus, that's the answer, right? But here, if you do not understand and you put the negative or positive negative, your answer will be totally different. So make sure you understand what is clockwise, what is counterclockwise. Any question before we try to see another semester? Wait, almost of you have okay, shall I move to next midterm or still any question?
Year exam, compulsory to write the counterclockwise or counterclockwise sign.
This one?
Yeah.
Okay. It is when you do, for example, for summation of force, right? Before, right? Now, do you normally write this one or not?
No.
Now, okay, there's a normal convention that we take, right? Like for example, x is to the right is positive, to the left is negative. Y is upwards negative, downwards positive, upwards positive, downwards negative is in 2D, right? For example. Now, for that method, normally for a moment counterclockwise is positive, right? Because your right hand rule. Tengok lecture lah, tengok lecture video, I will explain that. However, this will be very important if you do any mistake. For example, if I consider counterclockwise is positive, and if I write this one positive, right? In that case, this is correct, this is wrong, this is correct, right? Understand? But if I do, if this is the same, but it's actually I consider clockwise as positive, then this is wrong, this is right, this is wrong. So the number of right and wrong is different, right? If you do not right, I do not know, everything is wrong. So that's the implication. If everything is right, alhamdulillah, so normally not a problem. We just assume that that's it. But if any mistake, so we went to which is right, which is wrong, is based on this one, this implication, right? Because someone can take to the left as negative, positive, or downwards positive, especially if all of the force is downward. So someone do not like negative, so they positive downward. So it is plus. Something. So is it answer the question? So in the exam, it can be important if in the event of any small mistake like that. Okay, that's number one. Number two, if you do not declare, because this is another thing about the final answer. If the final answer is positive or negative, if you declare something in front, right, positive, and then suddenly get negative, it is understood that the negative is opposite. Similarly here, if you declare positive, clockwise or counterclockwise, whichever direction you take as positive and negative here, it means that one. Meaning, if I get negative, it means that it's the opposite of the direction I said as positive. If you do not declare that one, then there's also usually some mark there because it's not clear what you mean by that positive or negative. What direction is it? And normally in moment they will expect you to state whether it's clockwise or counterclockwise. So that's the two implication. Any other question? Can we go to the next midterm? So let's take a look at this one. Let's cover this one. Okay, this one. I just want to see whether you understand the question. Because for some students, the diagram seems complicated or intimidating. Those two parts, just focus on the first part. This one we'll discuss after this. This is logical question, but I think most of students fail to answer last time. You can imagine what to do? Okay, do you understand the question? A friction at sleeve A, so this is A here, can provide a maximum resisting moment of 1 to 5 Newton meter about x-axis. What do you understand by that?
The force is
Maybe the moment here, all of this is technical. There is a friction there that produce maximum 1 to 5 moment. Meaning this one can produce up to 1 to 5 Newton meter moment. So you understand? Okay. If force here is, this is actually equal to, this force is equal to 500 Newton. Determine if this force is adequate to turn the bracket. Bracket is this one. Meaning it's like this. When you have force here, can it actually turn or not? Because it says friction here, meaning that when you want to turn, there's a friction that counter that one. And that counter can go up to 1 to 5. So with this F, can it turn or not? Do you understand how to try to answer?
Find the moment of the F.
Can I?
Find the moment of the force.
Can you find a moment? Then how to know whether you can turn or not?
Well,
Yeah, you compare with 1 to 5. If this actually produce moment more than 1 to 5, then it can turn. If no, then this 500 Newton cannot turn. Because the friction will counter and it's still less than 1 to 5. You get that? So this is moment about what? From this understanding. Is it moment what? It gives me, yeah? Because this 1 to 5 is about x-axis. So you have a moment about x-axis. In that case, if you want to calculate moment about x-axis, so u will be what? U of x-axis. So what is the vector?
N.
I, right?
I.
Do you understand? It's unit vector of x-axis, right? So simply I, vector I. 1i plus 0j plus 0k. Or simply I, right? For this unit vector here. R from what? From where to where? So from here, from? So you just calculate RA, B, right? And F here, you have to use the alpha beta gamma for the vector. You want to try? Oh, it's too easy. Too easy. So you know what to do, right? Because in the end, when you put into the vector, you have, can you imagine? This one will be what? Because you say it's too easy, right? So I just, so M equal to U dot R dot F. So in terms of vector, what is the first row? 1, 0, 0, right? From I, that 1i plus 0j plus 0k. For R, it's x is, can you see from here? Negative 150, right? If you use in millimeter. And then 300, positive 300. And then 100. Everyone get the same? It's just from A to B. And then F is basically 500 cos alpha, which is, what is alpha? Okay, this is where many students get wrong. If you say 500 cos 60, you understand why is it wrong? Because this is not alpha. Alpha is from vector to positive x. Here. So many students will interact that. Is this beta? Yes, because it's positive y. This is gamma? Yes. But this is not alpha. So you have cos 120.
Yes.
Make sure you try question like this, because if you have never tried, you never know that there are tricks like that that can trap the student. Because normally you just take the value, right? This is 120, this is 500 cos 60, this is 500 cos 25. You calculate that, you get the value. And then you compare. Is it bigger or not than 1 to 5? This is actually easy to calculate, right? Because there's many zero here. If you calculate here, what do you get? It's 1, 300 times this one minus this one. What do you get? Just to see whether it's bigger or smaller than 1 to 5. Okay, 300 times 500 cos 45 minus 100 times 500 cos 60. Sama. Sama. What value that? Ada yang tu? 81. 81,000. Huh? Oh, okay. It's because this is in Newton millimeter, right? This is in Newton millimeter because here. So you have to change the Newton meter. You have to divide by 1,000. So ada ni. So all of you get 81. So basically the moment produced by this F about this is 81 Newton meter, right? So the conclusion is cannot. So you have to answer until that point. Even if you get that number, you still haven't answered. What is the question? Determine if the force is adequate. So not adequate. Cannot tell. Understood? Okay, do you understand the second part? If the force F can be applied at B, which is the same point, in any other direction, meaning not confined with alpha, beta, gamma, is it possible to turn the bracket with the same force? Meaning, if the force is still 500, but you can change the direction, can it actually turn? Kenapa? Kita boleh yes. How do you know? How to check? Okay, do you understand the question? Because 500 in this direction cannot turn, right? But if you can change the direction, so what will you do? Where will you change?
Turn to that x-axis.
This force in x-axis. Yeah? Maksudnya F is in which direction?
X.
F pula. Force F.
Huh?
Faham tak? Because that F in that given direction there, it cannot turn the bracket, right? But if the question means that if you can change the direction of F, even though the value is still 500, is it possible to turn? Macam tidur no tu kenapa? How do you suddenly get the conclusion no? Okay, what is the maximum moment that it can produce? In which direction? Perpendicular, right? Do you understand the concept? If okay, as I mentioned about now, if the force is here, right? Is that the moment? If the force is that, no, because it goes to this point, the distance 0. If it has a certain angle, there will be moment. But the maximum moment is straight down. Why? Because it's perpendicular. So what direction will give us exact perpendicular? It is straight, right? So that's what you have to do. Okay, if this is exactly straight here, what will be the value? Meaning what? Meaning that in this metric, what will change? It's still x-axis. R is still AB, but this one will be. It will be what? It will be what? 0, 0, 500. Because all are 500 upward. So try and see whether you can turn or not. Senang je, darab je. it more than 1.5 in Newton meter? Of course, you have to divide by, because this is in millimeter, right? Or otherwise you do 0.15, 0.3, 0.1.
More.
It's more, right? It's 150, right? So the answer is yes, by proving that. So if you have to understand the question and do it like that. Dan tiba-tiba tu yes, tak tahu pasal-pasal tekan matematik. So this is the type of question, if you never try, you never know what to do. Because it's like that. But if you have tried, and it's actually quite simple. Okay, to the last. Any questions before we go to the last? This one we have covered. This one we have covered. This one we have covered. So another one. This is the most basic. This is the last one. Alright, this one. Okay, the one that we have covered is only just part A and part B. Because this is moment about point O. This is moment about line OA, this is a moment about axis. You want to try? Oh, okay, this is too easy. The distance is, this distance D is 400 meter. Okay, you can try. Any of these two? Of course, this. Okay, what to do here? Because there's a lot of force. So just like before, right? When we do in 2D, right? We split into. So you just do one by one. Meaning, moment about point O is meaning R cross F, right? So R cross F here, plus R cross F here, plus R cross F here, plus R cross F here. Okay, faham tak? Kita harus makin malas. Tapi it's not difficult because the R is repeated, because this R is the same. And this R can be the same if you don't make this longer, it's actually that. And then you just use the same R. F is easy because this already I, K, you don't need to. So it's quite short. Okay, so you can try. In the meantime, I'll just return your quizzes. If your friend allow you to collect for them, you can. If they do not, then they'll leave it behind. I'll return next time. So this is one of the quizzes. This is for the sister. This is for the brothers. Only 4 and 5 minutes. So you pass around. And there's another one. In the meantime, any questions, etc. about that one? Because this is the previous semester. So this one I'll give from the back. So this is for the sister. Oh, you do not study? Oh, yeah. So. This one, do you have speaker? Okay, so tak ada lagi. Ada any question about the quiz? Ah, no. Tak pasti. Mana? Untuk apa? Okay, yang ni you masukkan dot ke? Darab. Ni dot. Macam mana saya nak tahu yang mana dot mana darab? No, my point is the way you write must be different between dot and multiply. So macam macam ni multiply. What saya nak assume ni, kalau saya assume ni multiply dia jadi kosong. Saya assume betul lah ni, tapi saya kata ni apa solat ni? Tapi dot should be, because normally apa benda pula tu? Lain. No, my point is because you letak titik dengan titik ni. Normally dot is a bigger dot. Macam contohnya Newton meter, you take Newton dot meter, it's just a dot. Tapi kalau dot tu dia kena tolak. Tapi saya tak tolak. Magnitude of? No. What is CD?
CD punya magnitude.
Apa maksud CD ni magnitude? Because R has a specific meaning. R is motion vector. Kalau cakap CD je, ni R ke F ke U ke macam mana saya? So brothers have taken F. So I assume no question? Kan ada question pasal quiz, tak puas hati ke? Okay, if there's nothing more, insyaAllah I'll let you free. We end the session here. Assalamualaikum warahmatullahi wabarakatuh. Of course, if you have any question why certain things in your quiz, you can ask. Sekejap. Sebelum tu, tarikh midterm, bukan you. You dah tahu ke tadi ada tanya time midterm, saya tak jawab. You semua tahu time midterm? You pula jawab, yang lain? Oh, kau tak? Betul. I think from the beginning of the semester kita dah beritahu kan? Tak ada? Yeah, brother, do you know the midterm date? Oh, this section, we have too many holiday ni. Okay. Nanti tak datang kita tak rasa. This one, right? Is it, right? Correct? October 22nd, 8 PM. Kau tak nampak? 22 is what day? One until 4. So what we are covering and what we'll continue to cover next week is part of the so make sure you understand everything